Welcome back. Section 8.3 is scheduling with priority lists. So, before we jump into priority lists, we need to look at scheduling with a project diagram versus independent tasks. So, yesterday we looked at independent tasks where anything can be done before or while something else can be done. It didn't matter the order that we put it in. Now we've actually got a picture that tells us this can't be done until this is done. So, I just want to do a couple examples and then we're going to jump straight into priority lists here. Okay, so take a look at project diagram number 1 on the left. Okay, task P, that's the only thing that can be done right off of the start. P leads into Q and R. Okay, if you look, P leads into Q and R. So R and Q cannot be done until P is finished. Q leads into S, which means S cannot be done until Q is finished. S leads into U, U cannot be done until S is finished. R leads into T, T leads into V, V into W, and then all three of these tasks lead to the end. Okay, so what this means when we go to schedule. P is the only thing that can be done right off the bat, and it takes 2 minutes. While P is being processed, while P is happening, nothing else can be done because P leads into every task that can be done after it. So that means processor 2 has to be idling during this time. Okay. Now that we've actually got a diagram instead of independent tasks, you can now have idle time before everything is finished. Okay, now P is finished. I always circle them when I schedule them and I cross them off as they finish. So once P is finished, Q can now be started and R can now be started. They are ready, raring to go. So Q can be started. It takes 3 minutes, so that takes me out to 5 minutes. R can be started. That takes me out to 1 minute. Of these two tasks, R is the first one to finish. Once R is finished, task T is ready to go. So when R is finished at minute 3, okay, R is finished here, T can now be started. So T is going to go right after that, and T takes 5 minutes, so it'll take us clear out to 8 minutes. So T has been scheduled, and it's still being worked on. Okay. As I go from left to right, Q is done at 5 minutes. As soon as Q is finished, task S is ready to go. So I can now schedule task S. That takes 3 minutes, so that takes me out to 8 minutes. As I read from left to right, 8 minutes is my next stopping point. At that point, task T is now finished and S is now finished. When S is finished, that means I can go ahead and schedule task U. That takes 2 minutes. When T is finished, I can either schedule V or W. Doesn't matter which one. Let's do V. At 10 minutes, task U is now finished. V is still working. They work until 11 minutes. But I can go ahead and schedule W because the only prerequisite for W was T had to be finished. Well, T's already done. So W can go ahead and be scheduled. And that takes me out to 14 minutes. At 11 minutes, V is done. And at 14 minutes, W is finished. So these last couple is idle time. Okay. It's very important that you keep track of what you have scheduled and what is finishing when. Okay, let's take a look at project diagram number 2. Let me switch colors here. Okay, I've got 2 tasks that can be started off the bat, A and C. I've got 2 processors, so one's going to start task A, one's going to start task C. Okay. As I move from left to right, the first processor to finish is processor 1. They finish at 4 minutes. They finish with task A. What can be done when A is finished? Well, I can work on B or I can work on D. Oh, actually, look at my project diagram. D cannot be done until A and C are finished. Both A and C lead into D. So the only task that's ready to go now is task B. So we schedule task B. As I go from left to right, the next processor finished is processor 2 with task C at 5 minutes. Okay, C is now finished, which means D is ready and E is ready. Okay, I'm going to go ahead and schedule D because it's our longest one. So that's 7 minutes. That takes me out to 12. So D is now scheduled. At 7 minutes, task B is finished. E is ready, so E can go ahead and be scheduled. That takes me out to 11 minutes. Everything is now scheduled. At 11 minutes, E is finished. At 12 minutes, D is finished. So this last minute or hour, whatever it is idle time. Okay, I'm going to skip down a little bit here. This should be the next part on yours. So, not only are we going to use these project diagrams now, we're going to use priority lists, which is just a list of all tasks prioritized based on the preferred order. I know many of you have chore lists and stuff at home or at your jobs. You get told, you know, this, and this need to be done. And most of the time they give you an order in which they want it done. This has to be done before you start on this task. This has to be done before you start on this task. That's what your priority list is. This is your to-do list. In order. Okay, so the way you're going to see these priority lists for tasks X and Y, X comma Y. So this just means, if possible, complete X before Y. Now, it doesn't always happen that way. You can't always do it depending on what can be done before something else. But if at all possible, if you can pull it off, do X before you do Y. So there's some options that are going to happen here. The first one, if task X is ready, then complete it first. If it's ready, complete it first. If task X is not ready, so it's ineligible, it can't be done yet, then move to Y and complete it. So move to Y and complete Y. And your last option, if X and Y are both not ready, then wait. So in other words, idle until one's ready. So the number of priority lists we can create in a project with m tasks is m factorial. Here comes that factorial button again. Okay, so for example, if I have 5 tasks, I have 5 factorial ways to write out my priority list, which means 5 times 4 times 3 times 2 times 1, which is 120 possible priority lists. Okay, there's some ground rules we need to talk about. Processors. At any moment during the projects, your processes are either busy, so they're doing a task, or they're idle. They're waiting for a task to finish. Remember, we already talked about the status of tasks. They're either ineligible, they cannot be done yet because something else needs to be finished first. They're ready to go, so everything's been done, there's just nothing open to do it. They're in execution, they've been started, they're still being worked on, or they're completed. They were started and finished. So we've got 3 different scenarios of scheduling with the priority list. First one, processors are all busy, so they're all working. You may have one processor free, so you're going to find and complete the first ready task from left to right in your priority list. If we have no ready tasks, then the processors must idle or wait for new ready tasks. Sometimes you might have more than one processor that's free. So at that point, we assign all ready, all of them. All of the tasks that are ready in left to right priority to all available processors. Any unassigned processors must idle for new ready tasks, and any unassigned but ready tasks will not be started until new processors are available. So sometimes you might have more tasks than processors ready to go. If that's the case, pick a task and leave the other tasks until something else opens up. So there's some steps that you need to think about as you complete these. Step 1, What tasks are now ready? Identify those tasks in the priority list. Which ones are ready to go right now? So, in other words, all arrows leading to the task have been finished. Step 2, your priority list. What is the first ready task in the list from left to right? Assign that to the first available processor in the timeline and schedule it. And step 3, if multiple tasks are ready in the priority list, then you can assign to available multiple processors. If there's no task ready, you will wait or idle until the tasks are complete in the schedule so you can move on to the next one. Cross out the task in the priority list as you complete them. Okay, we've got several examples we're going to go through. I've got 3 examples and then we've got 2 practice problems we're going to look at. Okay. So, here is your project diagram. Okay. Here is the priority list that they want us to do these tasks in. Okay. This is your priority list. So, the first thing I like to do is I like to go through and I like to circle which ones can be done right off the start. So, in my priority list, my starting tasks are A, B, and C. So this is ready, this is ready, this is ready. Okay, so A is the first thing that they want us to complete. It's ready to go, so I'm going to go ahead and schedule that. As I schedule, I check them off or cross them off in my priority list. As I schedule, I also circle them on my picture. Okay, this is all about keeping yourself organized. Processor 2 needs something to work on. B is ready, so I'm going to go ahead and schedule B. And that takes 5 minutes. So A and B are scheduled. Processor 1 is busy, processor 2 is busy. Okay. The first processor to finish is going to be processor number 2. Okay. They're going to be finished with B. When task B is done, is anything else ready to go? C was ready to go off the bat, so I can go ahead and schedule C. C takes 7 minutes, so that's going to take me clear out to 12. So C is now scheduled. Okay. At 6 minutes, task A is now complete. So A is complete, B is complete, which means D is now ready to be scheduled. So I can go ahead and schedule D. That takes me up to 8 minutes. Okay, so D is scheduled. The next processor to finish is processor 1 at 8 minutes. And they're going to finish task D. The only thing left to finish is task E. But look what has to happen first. C has to be done before E can be started. C is not done until 12 minutes, which means processor 1's going to sit on their butt and do nothing until C is finished at 12 minutes. At that time, we can now schedule task E, which takes 5 minutes, which means my other processor will do nothing until that task is completed, and my finishing time is 17. All 5 tasks are complete. Okay. Same picture, new priority list. Let's see if this changes our scheduling at all. Okay, again, there are only 3 tasks that can be done starting off the bat, A, B, and C. So C, B, and A. Okay, even though we're supposed to do the priority list in order, E can't be started yet, it's ineligible. D can't be started yet, it's ineligible. So the first task in my priority list that's eligible to be started is C. So we go ahead and schedule C. Processor 2 needs something to work on. The next available task in my priority list is going to be B, so we have to go ahead and schedule B. Okay. As I go from left to right, my first processor finished is processor 2 at 5 minutes. They complete task B. The only task that is ready at this point is task A, so we're going to go ahead and schedule that. That's 6 minutes, so that takes me to 11 minutes. Okay, at 7 minutes, C is now finished, which makes E now eligible. D is still not eligible until 11 minutes is up. But E can be scheduled, so E is going to go next, and that takes us to 11 minutes. At 11 minutes, A and E are both finished. So D can now be scheduled. That takes us out to 13. Oops. Sorry, guys. E takes 5 minutes, so that should take us out to 12. My bad. So at 11 minutes, A is finished. So D's got to be scheduled down here and takes 13 minutes. So then we've got 1 minute of idle time. So my finishing time now is 13 minutes. See how your finishing time has changed because of your priority list, depending on how you want tasks done. Again, double check and make sure all of your tasks have been scheduled. And they have. All of your tasks are complete. And we're ready to go. Okay, we've got one more. Again, same graph, different priority list. So, again, right off the bat, A is ready, B is ready, C is ready. So A is ready, C is ready, B is ready. A is the first one on my priority list, so we get scheduled first. That takes 6 minutes. C is ready, So that gets scheduled next because that's my next ready one on my priority list. That takes 7 minutes. At the end of 6 minutes, A is now finished. The only task ready to go at that time is B. Okay, so B is now scheduled. That takes 5 minutes. That takes me to 11. The end of 7 minutes, C is now finished, which makes E eligible. So E can now be scheduled. That takes 5, so that takes me to 12. At the end of 11 minutes, B is now finished, which makes D eligible. So D can now be scheduled. That takes me to 13, which means we have idle time here. At 13 minutes, or at 12 minutes, E is finished. At 13 minutes, D is finished. So we've got a finishing time of 13. Okay. Practice problems. Okay. 3 tasks ready off the bat with this diagram. A, B, and C are ready. So A, C, and B are ready. Priority list wants us to do A first. That takes 5 minutes. C second. That takes 6 minutes. So A is scheduled. C is scheduled. At the end of 5 minutes, A is finished, which makes F eligible. The next one in my priority list that's eligible is B though. So we're going to go ahead and schedule that. 7 minutes takes me out to 12. At 6 minutes, C is now finished. D is not eligible yet, and neither is E. So F is going to be scheduled next. That finishes after 3 minutes, so that finishes at 9. So F is scheduled. The next processor done is processor 2 at 9 minutes. They finished task F. At that point, E is now eligible. D still is not because B is not finished yet. B leads into D. So we can go ahead and schedule E at this point. And E takes 9 minutes. So that's 2, 4, 6, 8. That takes me to 18. At 12 minutes, B is now finished. And D is eligible. So we can go ahead and schedule D. That takes 3 minutes. Everything is scheduled now. At 15 minutes, D is finished. At 18 minutes, E is finished, which means we idle and we have a finishing time of 18. And your last example. Okay. The only tasks that are ready right off the bat are D and E. So E is ready, D is ready. So the first thing we should schedule is E. So E is going to go to processor 1. And D is going to go to processor 2. So they're scheduled. Both of them are scheduled. Okay, the first processor to finish is processor 2 at 4 minutes. They finished task D. When task D is finished, A is now eligible. F is not though. E needs to be done and D needs to be done before F is ready to go. So we can now schedule A. That takes me out to 11 minutes. A is scheduled. The next task to finish. Ooh, I put that in the wrong processor spot. My bad. Give me a second. A doesn't go up here. So sorry. A goes down here. 5 minutes, that takes me to 9. Okay. The next processor to finish is processor 1. They finished task E. When E is finished, F is now eligible and B is now eligible. So F and B are now ready to go. Well, the next one in my priority list happens to be F, so that has to be scheduled first. And that takes 3 minutes. Now both processor 1 and 2 finish, both at 9 minutes. They finish A and F. Okay. When A and F are finished, C is now eligible. So my last two tasks are both eligible. B should come first. That takes me out to 17. C takes me out to 11. So B and C both are scheduled. C finishes at 11 minutes. B finishes at 17. So we've got idle time. So my finishing time here is 17 minutes. Okay. Moving on to section 8.4, decreasing time algorithm. Okay, all this is a new priority list, one that they don't give you. So instead of them giving you the priority list, you have to come up with your priority list. Decreasing time means exactly that. It has to go from greatest to least. So, reminder, the priority list has nothing. That first word there is nothing to do with the president relations. The list states the preferred order of the completed task, but the diagraph actually shows you the requirements to start a task. Okay? Our goal is to try and find good priority lists to get the shortest possible processing time. So, our first strategy, which is what we're going to talk about, the decreasing time, is to do longer jobs first and leave the shorter jobs for last. I don't know about any of you, but that's how my brain works. If I can get the long, drawn-out stuff done first and leave the short 5-minute things that I can do last minute at the end, I feel like I've accomplished more. Okay, so decreasing time priority list is just the decreasing order of your processing times. If the task has the same processing time, then you can randomly order them in whatever order that you want. Okay, they just call this the decreasing time algorithm. It's just a process of scheduling. Okay, so your algorithm is just creating that priority list. So, the first thing we have to do is where you have to actually create the priority list because they're not going to give it to you this time. So we've got 5 tasks, A, B, C, D, and E. And we need to order these from least to greatest first. Or I'm sorry, from greatest to least first. So my longest task is task C. It takes 7 minutes. My next longest task is A. It takes 6 minutes. Okay, B and E both take 5 minutes, so it doesn't matter what order you put them in. So B and E. I have a thing with alphabetical order, so you'll see me put them in alphabetical order. And finally, D is my shortest amount of time. It takes 2 minutes. Now that we have the priority list, we can go ahead and start to schedule. Right off the bat, A, B, and C are all eligible. So A, B, and C are all eligible. According to my decreasing time priority list, C should be scheduled first. So I'm going to go ahead and schedule C. And A should be scheduled second. So I'm going to go ahead and schedule A. So both processors are working up until 6 minutes. At 6 minutes, processor 2 is done with task A. Nothing else becomes eligible when task A is finished because D is not ready until A and B are finished. Okay, so we just need to move on. Your next ready eligible task is B. So B gets scheduled next. That takes me to 11 minutes. My next processor finished is processor 1 at the end of 7 minutes. They are done with task C. When C is finished, that makes E eligible and ready to be scheduled. So we're going to go ahead and schedule E because that's the next task ready. That takes me to 12 minutes. At the end of 11 minutes, processor 2 finishes with task B. And now D is eligible. So once B is finished, D is now eligible, and that takes me to 13 minutes. All of my tasks have been scheduled, which means we idle for this last minute, which means my finishing time is 13. So it's no different than scheduling with priority lists, except now you need to come up with the priority list. It will not be given to you. Example number 2. We need to come up with the priority list first. So my first task can be task E, 9 minutes, followed by B, 7 minutes, C, 6 minutes. You don't have to write the times in as you're writing the priority list. It's just a habit. A, and then D and F can be done. They have the same amount of time. Okay. Let's see what's eligible. A, B, and C are all ready to go. So B, C, and A are the only ones ready to go off the bat. The first one on my priority list is B, so we go ahead and schedule that. Followed by C, so we go ahead and schedule that. The first task finished is C. Processor 2 is finished with C at 6 minutes. Nothing else becomes eligible at that point because D has to wait for B to finish. So my only thing that is ready to go that I can schedule is A. So A gets scheduled. That takes me to 11. At 7 minutes, B is finished, which makes D eligible now. So D is going to go ahead and get scheduled. That takes me out to 10. D finishes at 10 minutes. but there's nothing eligible. A's not done yet, so I can't do F. If F's not done, I can't do E. So we're going to idle there for a minute. At 11 minutes, A is now finished, which makes F eligible. So F is going to get scheduled. It doesn't matter which processor you give it to because both of them are opened. So F is now scheduled. There's nothing for processor 2 to do until F is finished. So processor 2 is going to idle until 14 minutes. At that time, F is finished and E is now eligible. 4, 6, 8. Again, you can give it to any processor you would like because both are open. I like to flip-flop and not give one processor too much idle time. It confuses me. So E takes out to 23 minutes, which means processor 1 will idle till 23 minutes. So your finishing time here is 23. Last one. Decreasing time priority list first. B. Followed by E. Followed by A, D, F, and C. B, E, A, D, F, C. Okay? All right. D and E are the only two ready off the bat, so E and D. E is the first one on my priority list, so it gets scheduled first, and that's 6 minutes. D is 4 minutes. So both of these are scheduled. At 4 minutes, D is now complete. That makes A now eligible. Nothing else becomes eligible yet. So A gets scheduled next. That takes me out to 9. At 6 minutes, E is now finished, which opens up B and F now. Well, according to my priority list, B needs to be done before F, so B gets scheduled next, and that takes 8 minutes. That takes me out to 14. At 9 minutes, A is now finished, which makes C, no, does not make C eligible. But A is finished. Okay, so when A is finished, the only one eligible is F right now, so F is going to be scheduled. That takes me out to 12. At 12 minutes, F is now finished, so C is now eligible. So we can go ahead and mark C. C is done at 14 minutes. Everything is now scheduled, so my finishing time here is 14 minutes. The weakness of this is the precedence relation is not considered. What I mean by this is we prefer to get things with more tasks in front of it to be finished before other tasks. Okay, I'd rather get these first two tasks. Hold on, let me erase this for a second. I'd rather go ahead and get D and E finished first because they're right off the bat. Well, my priority list is not making them a priority. Okay, so we're not concerned about what should be done right off the bat. We're concerned about how long each individual task takes. Okay, so that is a weakness to this method. We're not concerned with what can be done. We're concerned with how long does it take. Your homework tonight is going to be a take-home quiz on 8.2, 8.3, and 8.7. Okay, you have your notes. Please do not use each other. This is on the honor system. Your quiz is due tomorrow. No excuses. If it is late, it is an automatic 5 points off every day that it is late. Please make sure you have it ready, and I will see you tomorrow.